Okay, we're going to talk about some of the different interactions you can use on both the scene and the model. So for example, setting the view orientation. What this means is we have the canonical views, front, back, top, bottom, left, right, and ISO. So you can use the view object to set these view orientations. We support animating that view. So whenever you change the camera, it can be animated. You just pass it in an integer representing the number of milliseconds, and we'll handle doing the interpolation between the cameras for you. Setting the render mode. So this is an important one. So the render or draw mode defines the overall visual style of Communicator. So we support just a standard shaded view. We also support a wireframe view, or an only render faces, or we support hidden line mode also, which gives you like a matte background and then will display certain edges to kind of give the view more of a look as if it was a drawing, like a 2D drawing. And we also support an X-ray view, which is interesting in that it will basically make everything else transparent except for a particular part that's selected. So if you want to highlight like where a particular part fits in a bigger assembly, you can select that part and then set X-ray mode, and you'll be able to kind of see where it is inside the assembly. And then moving the camera is something we talked about previously, but we have a couple of utility methods. So we can center the camera on a node. So basically, if you want to kind of focus on a certain node, you can arbitrarily set the camera to whatever you want, or you can reset the camera. Now, resetting the camera will take the camera back to the original view that is authored in the file itself. So all files have a default camera, and this will reset it to that camera. Okay, so on the model, some of the interactions that you'll be using are the getNode, getNode star functions. Now, these methods are pretty essential for working with the structure of the model. So you can see here, working to traverse the model tree is I'm not going to start over. Can we edit that out?
We can edit that out.
We can edit it out. We have the technology.
Just take a little pause, a blank space, and then start again on this slide. Go ahead.
Okay, so I'm gonna. Okay, so we're talking now about model interactions, and some of the common operations we'll be using on the model are these getNode star functions. And the getNode star functions are used to traverse the model tree. Now, this is important if you want to create your own representation of the model hierarchy, and also for just business logic that may require knowing like the parent or children of a model. So, for example, we can get the root node, and from there we can say, okay, maybe we can get its children, and for any node we can also get its parent. So this allows us to build up that structure, and also allows us to see like maybe what siblings the node has. So any type of interaction that you want to call out, maybe groups of related nodes, you would use these getNode star functions. We can also, a couple other ones that aren't listed here that are going to be important for you. You can also get the node's name, which you obviously want if you're going to want to build up this tree, but also you can get the node's type. So some of the node types that we have are, say, instances, or bodies, or assembly nodes. So any type of information that you can get from the node, we have a corresponding method. Also, getting the node's properties is also going to be in this family of methods, which we have right here. So we can also get the properties and its matrix. Now, we also get its when we say node matrix, you can also specify if you want the local matrix or its net matrix. So that's handy there. So also with the model, we can modify the scene. So the view only handles the display, but the model, we can also affect the scene itself. Okay, and what this means is that we can actually insert our own geometry into the scene. So for example, if you want to maybe insert a wireframe box around particular objects that are selected, or insert 3D arrows to call out certain parts, you would do this by creating your own mesh. And I think we have an example of that we'll work through a little bit later. But anything you can create, or anything you want to create, you can insert with creating a mesh. And once a mesh is inserted, it's just as if it was any other node in the scene. So you can set its visibility, its color, any properties that mesh should have. Now, one thing we want to say here is that we don't recommend using this for very large meshes, because we talked a little bit about this optimized mesh data in the past, but the data insert this way is not as optimized because it just goes straight into the system at runtime. We don't have that conversion step to really optimize that data. So you wouldn't want to build up a giant model by using this, but if you just want to insert some helper geometry or markers or something like that, you can create a mesh. And one final thing on the model here is on-demand stream. For on-demand streaming, you can request nodes to be loaded in through the model. Okay, so in order to load additional models, there's a number of things that we have to take into account. So most basic cases will start with a particular model that we want to view. But if we want to load in another model, we need to make sure that the SC server app that's running on our server knows where that model is. Most oftentimes, you'll have a repository that just has all your models there in the same co-location. And in that case, it's very easy. All we have to do is specify the name of the new model. So there's a couple different ways that we can tell our model object to load in an additional SC model. So we can either switch to a new model. In that case, it's essentially throwing away all data that is currently in the viewer and replacing it with this new model. Or we can say, load an additional subtree from another model. Now, when we say load subtree, what this is going to do is it's going to take the entire model tree from this new model and paste it into our existing scene, along with all the graphics data. So we can specify a node that it's going to paste into. Oftentimes, it'll just be the root node of the scene. And it'll be just as if we created a brand new connection to that new model, except that we won't throw away anything that's already in the scene. So this allows us to load multiple models dynamically. We don't have to specify them all up front. So the result is a flexible system that allows us to really respond to what the users need, in the sense of maybe they don't know all the models that want to load when the session starts. So the example that we go back to is like a furniture configurator. Maybe there's 30 different types of a particular furniture piece, but we don't know which one the user is going to want to pick. As long as they all have a unique name and they're all co-located, we can just load them in one at a time. And we can also remove them too by using a method on the model to delete nodes. We can